Hello, my dear students, welcome back to aqueous chemistry classes. Here we are in lecture number 6 on redox reactions. In this video, we will discuss the oxidation number concept of oxidation and reduction. According to the oxidation number concept of redox reactions, oxidation and reduction can be defined as follows. The process of increase in the oxidation number is called oxidation, while the process of decrease in the oxidation number is called reduction. It is obvious that the increase in oxidation number is called oxidation, while the decrease in oxidation number is called reduction. The oxidation number concept is the most complete concept of redox reactions, and almost all the redox reactions can be explained with the help of this concept. Let us illustrate this concept of redox reactions taking the following example. Hydrogen reacts with Cl2 forming HCl. Please recall that the electronic concept of redox reactions fails to explain this reaction because this reaction involves neither loss nor gain of electrons. Rather, it involves sharing of one electron each between hydrogen and chlorine atoms. But this reaction can easily be explained on the basis of oxidation number. The oxidation number of hydrogen, which is in the free state, is equal to 0. The oxidation number of chlorine, which is also in free state, is also equal to 0. On the other hand, the oxidation number of hydrogen in the product, which is combined with non-metal, is +1, while the oxidation number of chlorine in HCl is -1. It is obvious that in this reaction, the oxidation number of hydrogen increases from 0 to +1. The oxidation number of hydrogen increases from 0 to +1, and therefore hydrogen is oxidized or hydrogen undergoes oxidation. On the other hand, the oxidation number of chlorine decreases from 0 to -1. The oxidation number of chlorine decreases from 0 to -1, and therefore and hence chlorine is reduced or it undergoes reduction. The following types of chemical reactions are redox reactions. Combination reaction. If two or more elements combine together forming a compound, it is certainly a redox reaction. Let us illustrate with an example. Magnesium element combines with oxygen element forming magnesium oxide. The oxidation number of various elements involved in this reaction are given above with blue digits. The oxidation number of magnesium, which is in free state, is equal to 0. The oxidation number of oxygen in O2, which is in free state, is also equal to 0. The oxidation number of magnesium, which is an alkaline earth metal, and in combined state its oxidation number is +2, while the oxidation number of oxygen in the magnesium oxide is -2. It is obvious that the oxidation number of magnesium increases from 0 to +2. Therefore, magnesium is oxidized to MgO. On the other hand, the oxidation number of oxygen decreases from 0 to -2, and hence O2 is reduced to MgO. O2 is reduced to MgO because its oxidation number decreases from 0 to -1, while Mg is oxidized to MgO because its oxidation number increases from 0 to +2. Decomposition reactions. The decomposition of a compound into a smaller fragments, at least one of them being an element, is a redox reaction. It means if a compound decomposes into a smaller fragments and one of the products is an element, then it is a redox reaction. An example is given below. Potassium chlorate decomposes on heating to KCl and O2. The oxidation numbers are given. The oxidation number of potassium and alkali metal in the combined state is +1. In the reactant also and in the product, the oxidation number of potassium is also +1. The oxidation number of chlorine in KClO3, the reactant, is +5, while in KCl, the product is -1. On the other hand, the oxidation number of oxygen in KClO3, that is reactant, is -2, while in product O2, its oxidation number is 0. It is clear that the oxidation number of chlorine decreases from +5 to -1, while the oxidation number of oxygen increases from -2 to 0. Therefore, in this reaction, KClO3 is reduced to KCl because the oxidation number of chlorine decreases from +5 to -1. On the other hand, KClO3 is oxidized to O2 because the oxidation number of oxygen increases from -2 to 0. Metal displacement reaction. A more reactive metal displaces a less reactive metal from the aqueous solution of its salt. A more reactive metal displaces a less reactive metal from the aqueous solution of its salt. Such type of reaction is called metal displacement reaction, and it is a redox reaction. Let us see an example of metal displacement reaction. When zinc strip, not copper strip, is dipped into the aqueous solution of CuSO4, reddish brown precipitate of copper is obtained and the blue color of the solution becomes colorless due to the formation of ZnSO4. Let us see the colors of various species involved in this reaction. Copper sulfate is blue colored in aqueous solution, while zinc is white colored. ZnSO4 in aqueous form is colorless, while copper is brownish red or reddish brown. As a result of this reaction, the blue color of the solution is discharged and a brownish red precipitate or a brownish red layer of copper is formed on the white zinc strip. The oxidation numbers of various elements in this reaction are given here. The oxidation number of copper in CuSO4 is +2, while in free state in the product the oxidation number of copper is 0. The oxidation number of zinc in the free state is 0, while the oxidation number of zinc in ZnSO4 is +2. It is obvious that the oxidation number of copper decreases from +2 to 0, while the oxidation number of zinc increases from 0 to +2. Here, copper sulfate is reduced to copper because the oxidation number of copper decreases from +2 to 0. On the other hand, zinc is oxidized to ZnSO4 because here the oxidation number of zinc increases from 0 to +2. Non-metal displacement reaction. It is similar to metal displacement reaction. A more reactive nonmetal displaces a less reactive nonmetal from the aqueous solution of its salt. It is called non-metal displacement reaction and it is a redox reaction. Let us illustrate it taking the following example. When chlorine gas is passed through the aqueous solution of potassium iodide, solid iodine is precipitated. The oxidation numbers of underlying elements are shown above. The oxidation number of iodine in Ki is -1, while in product I2 the oxidation number of iodine is 0 because it is in free state. The oxidation state of Cl2 in the reactant is 0 because it is in free state, while in KCl the oxidation number of chlorine is -1. It is obvious that the oxidation number of chlorine decreases from 0 to -1, while the oxidation number of iodine increases from -1 to 0. Here Ki is oxidized to I2, while Cl2 is reduced to KCl because in the above reaction Ki is oxidized to I2 due to increase in oxidation number from -1 to 0, while Cl2 is reduced to KCl because its oxidation number decreases from 0 to -1. However, the acid-base neutralization reactions are generally not redox reactions because they don't involve the change in oxidation number of any element. Let us see an example. NaOH reacts with HCl forming NaCl plus water. Base reacts with acid forming salt and water. It is called acid-base neutralization reaction and it is not a redox reaction. The oxidation number of sodium in the reactant is +1 and in the product it is again +1. The oxidation number of oxygen in the reactant is -2 and in the product it is also -2. The oxidation number of hydrogen in the reactant is +1 here also, and in the product the oxidation number of hydrogen is again +1. Thus we see that in this acid-base neutralization reaction the oxidation number of no element changes and hence it is not a redox reaction. It is simply an acid-base neutralization reaction. The thermal decompositions of carbonates and bicarbonates are also not redox reactions. Calcium carbonate decomposes on heating, forming CaO and evolving CO2 gas. The oxidation number of calcium in CaCO3 in the reactant is +2 and the oxidation number of calcium in calcium oxide, the product, is also +2. The oxidation number of carbon in the reactant is +4 and in the product it is also +4. The oxidation number of oxygen in CaCO3 is -2 and in both the products the oxidation number of oxygen is -2. And hence it is not a redox reaction because the oxidation number of no element changes. Let us see the thermal decomposition of sodium bicarbonate, which produces sodium carbonate, CO2 and H2O. Oxidation numbers are given above. In this reaction also the oxidation number of no element changes, as it can be explained as above. and hence it is also not a redox reaction. Disproportionation reaction. The redox reaction in which the same substance is oxidized as well as reduced is called a disproportionation reaction. Please see it again. The redox reaction in which the same substance is oxidized as well as reduced is called a disproportionation reaction. Let us see an example. When sulfur is heated with hot and conc NaOH solution, sodium sulfide and sodium thiosulfate are formed. The oxidation number of sulfur in the reactant side is 0 because it is in free state. In sodium sulfide, the oxidation number of sulfur is -2, while in sodium thiosulfate, the oxidation number of sulfur is +2. Thus, we see that sulfur is reduced from 0 to -2, as well as sulfur is oxidized from 0 to +2, and hence it is a disproportionation reaction. It can be represented diagrammatically also as follows. Sulfur is oxidized to sodium thiosulfate from 0 oxidation state to +2 oxidation state. At the same time, sulfur is reduced to Na2S, that is from 0 oxidation state to -2 oxidation state. Thus, it is a disproportionation reaction. It is a disproportionation reaction in which sulfur is oxidized as well as reduced. Comproportionation reaction. The redox reaction in which two different oxidation states of an element converge together to a single intermediate oxidation state is called a comproportionation reaction. Please understand it again. The redox reaction in which two different oxidation states of an element converge together to a single intermediate oxidation state is called a comproportionation reaction. Let us illustrate it taking the following example. H2S reacts with SO2 forming sulfur. The oxidation number of sulfur in H2S is -2, and in SO2 the oxidation number of sulfur is +4. These two oxidation states of sulfur -2 and +4 converge, meet to a single oxidation state 0 in the product. 0 oxidation state is intermediate between -2 and +4, and hence it is a comproportionation reaction. It is also obvious from this figure also. H2S undergoes oxidation to sulfur because its oxidation number increases from -2 to 0. On the other hand, SO2 is reduced to sulfur because its oxidation number decreases from +4 to 0. It is obvious that +4 oxidation state and -2 oxidation state of sulfur in this reaction converge to a single intermediate oxidation state and it is 0. Therefore, it is a comproportionation reaction. Now, the time for self-assessment. Identify the substances undergoing oxidation and reduction in the following reaction on the basis of oxidation number concept. A reaction is given below and we have to identify the substances which are undergoing oxidation and reduction. Here is the reaction. FeCl3 reacts with H2S forming FeCl2, HCl and sulfur. We have to identify which substance is oxidized and which substance is reduced. Please pause the video and try to solve it within 3 minutes. Here is the answer of problem. The given equation is, and the oxidation number of various elements involved in this reaction are. the oxidation number of Fe in FeCl3 is plus 3, while in the product the oxidation number of Fe is plus 2. On the other hand, the oxidation number of sulfur in H2S, that is reactant, is minus 2, while the oxidation number of sulfur in the product S is 0 because it is in free state. It is obvious that FeCl3 is reduced to FeCl2 because the oxidation number of iron decreases from plus 3 to plus 2. On the other hand, H2S is oxidized to S because its oxidation number increases from minus 2 to 0. In this reaction, FeCl3 is reduced to FeCl2, while H2S is oxidized to S. Another problem for self-judgment. Identify the substances undergoing oxidation and reduction in the following reaction on the basis of oxidation number concept. Same type of problem. When NaOH reacts with N2O3, sodium nitrite and water are formed. Here is the answer. The given equation is NaOH plus N2O3 give NaNO2 plus H2O. The oxidation number of various elements involved in this reaction are given below. Sodium plus 1 in the reactant, and in the product it is again plus 1. The oxidation number of oxygen in NaOH as well as in N2O3 is minus 2, and the oxidation number of oxygen in NaNO2 as well as oxygen in H2O is minus 2. The oxidation number of hydrogen in NaOH is plus 1, and in H2O it is again plus 1. Thus we see that the oxidation number of no element changes during this reaction, and hence it is not a redox reaction. It is a base. N2O3 is an acidic oxide. They react together forming sodium nitrite, salt and water. It is simply an acid-base reaction involving no change in oxidation number, and hence it is not a redox reaction. Thank you for watching the video with concentration. Please like, share and subscribe it so that I may bring more useful videos before you in future. Thank you again.